The quadratic formula. Our learning goal today is to use the quadratic formula to solve the roots of unfactorable equations. Please ensure you have the lesson printout so you can follow along with this video. Before we begin learning about the quadratic formula, let's recall. What is the solution to the square root of 16? If you said 4, you're partially correct. We know that a square root of a number is a number that when you multiply it by itself, gets back to the original number. So if we took 4 and we multiplied it by 4, or 4 squared, we would get 4 times 4, which is positive 16. So this is one of our solutions. But there is another solution. If we took negative 4 and multiplied it by itself, we would also get positive 16. Negative 4 times negative 4 is positive 16. In other words, negative 4 squared is equal to positive 16. So we can see there are two distinct solutions from a square root. There's a positive square root, so we have positive 4, and we have a negative square root, negative 4. We will be using this concept when talking about the quadratic formula. Let's try to determine the roots or x-intercepts of the relation y is equal to 2x squared plus 8x plus 1. Typically, when we're trying to find the x-intercepts, we would set y to 0, and we would try to factor this side right over here. Let's try factoring it. We can see this is a complex trinomial, so it'll be a times c, which is 2 times 1 in this case, which is equal to 2. So two numbers that multiply to 2, but add up to b, and b is 8 in this scenario. So we have two numbers that multiply to 2 and add up to 8. If we went through all our different factors of 2, we can see there's only a couple. It's 1 and 2, and then 2 and 1. And no combination of this will get us to 8. So we would say that this equation is unfactorable. But are there roots to this equation? If we convert to vertex form and graph it, we can determine where the vertex is and see if there's actual roots to this relation. So let's go ahead and try that. So our whole idea right now is we want to graph this, or at least find the vertex. We know it opens upwards because a is positive, and if it's below the x-axis and opens upwards, there must be roots. So let's see if that's the case. Let's convert to vertex form, and we'll use the completing the square technique to do it. So the first thing we want to do to complete the square, we're just going to factor out 2 from our first two terms to get x squared by itself. And now we want to add half of b squared and subtract half of b squared. In this case, our b value is 4, so we're going to have 4 divided by 2 squared, and this is going to be equal to just 2 squared, and that's equal to 4. So let's add and subtract that right after our b term. Plus 4 minus 4, and then we have our plus 1 on the outside. And then, you know, the first 3 terms here factor into a perfect square, so let's go ahead and do that. We know x squared plus 4x plus 4, and that's just going to be, that's just going to be x plus 2 squared. We still have the negative 4 within this bracket, and we have this 2 on the outside. So we just want to multiply this 2 into this negative 4 here. So we'll get y is equal to 2 bracket x plus 2 squared minus 8 plus 1. And we just have to add these last two terms here. Y is equal to 2 bracket x plus 2 squared minus 7. Okay, so this is our vertex form. So this is our vertex form of the same equation, and we know our vertex can be read from this form. It's the h and k value. And we know h here is -2 and our k is -7. So we can plot this point on our graph, which is going to be -2, -7. Oh, right over here. And we know that a is positive, so it should open upwards. Now we know it should have roots somewhere along the x-axis here. We just have no idea what they are. We know that it opens upward because a is positive, and we know that the vertex is below the x-axis, and therefore it should have roots. But how then can we solve for the x-intercepts that don't factor nicely, yet still exist? So we actually have a formula which can solve for our roots or x-intercepts for a quadratic equation in the form 0 is equal to ax squared plus bx plus c. So basically when y is equal to 0, it'll tell us what our x's are. And it looks like this. X is equal to -b plus or minus b squared minus 4 times ac all divided by 2a. I know it looks complicated, and it is, but when we break it down into its components, it's not so bad. And we're just going to practice using this formula to solve for our roots. So let's practice using the quadratic formula. Example 1. State the x-intercepts of each of the following quadratic relations. Y is equal to 2x squared plus 8x plus 1. This is the same relationship that we saw before. The first thing we can do is to just list what our a, b, and c values are from our standard form here. We see a is 2, b is 8, and c is 1. We could then start plugging these into the quadratic formula. I always like to plug mine in using brackets. So I have b here, so negative b, so negative bracket 8, plus or minus the square root of b squared, which is 8 squared, minus 4 times a, which is 2, times c, which is 1, all divided by 2 times a, which is 2. So you're going to get something that looks like this. The first thing that we're going to do is we're going to follow a bed mess, and we're actually going to do everything that's underneath the square root. So we have -8, and we could actually simplify this just to -8, plus or minus 8 squared, which is 64, minus 4 times 2, which is -8, times 1, which is still -8, all divided by 2 times 2, which is 4. And now we can simplify what's underneath the square root again. That's the 64 minus 8. So we still have the -8 plus or minus the square root of 64 minus 8 is positive 56 divided by 4. So now we're going to get something that looks like this. And this is where it splits up. Remember, when we take the square root of something, we get a positive and a negative solution. So the same thing's going to happen here. We're going to split it up to a positive and negative solution. We're going to have -8 plus the square root of 56 divided by 4. And we're going to have -8 minus the square root of 56 divided by 4. And so we could actually calculate what the square root of 56 is. So if we do that, we're going to get the square root of 56 is going to be positive 7.48 divided by 4 on this side. And on this x, we're going to get -8 minus 7.48 on this side. And these we can just calculate to get our numbers here. So let's do this. -8 plus 7.48, that's -0.52 divided by 4. And on this side, if we do -8 minus -7.4, we're going to get -15.48. And we're just going to divide both of these by 4 to get our final x values. So here we're going to get x is equal to -0.13 approximately. And here we're going to get x is equal to -3.87. Okay, so 3.87. So these are going to be our x's here. And you can see they're decimals, and there's no other way to solve them except for using this formula here. So our x-intercepts are going to be x is equal to negative 0.13 or x is equal to negative 3.87. So this is how we use the quadratic formula when we can't factor our quadratic equation. Now, we should only really use this when we can't factor, because factoring is a faster method than this. However, if you're stuck with factoring and you don't know how to do it, you can always use this formula. It'll work with any quadratic if you want to find the x's. So there's the quadratic formula. Let's try a few more examples just so you can get it down. Okay, so let's look at our equation here. Y is equal to 3x squared minus 9x minus 2. And let's see if we can factor this to solve for what our x's are. So we have to look for two numbers that multiply to a times c. So a times c, which is going to be 3 times negative 2, which is negative 6. So two numbers that multiply to negative 6 but add up to b, which is negative 9. So let's look at all our factors of negative 6 and see if any of them add up to negative 9. So we'll have 1 and 6, and then we'd have 2 and 3, and then it would repeat again. And so if we threw our negatives on here, we see 1 plus negative 6 is negative 5, and 2 plus negative 3 is negative 1. So it's none of those ones. And if we looked on the other side, if we made these ones negative, we'd still get positive 5 here and positive 1 here. So it's none of these. So we can see it can't factor. So we can go straight to our quadratic formula. And let's just write down what the quadratic formula is right over here. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, and before we get to plugging everything in, let's just write down what our a, our b, and our c is. So our a is 3, b is negative 9, and c is negative 2. Okay, so let's begin. Let's start plugging in our values into our quadratic formula. So I always, again, like to put my variables into brackets. So we have b here, so negative b is going to be negative negative 9, plus or minus the square root of b squared, which is negative 9 squared, minus 4 times a, which is 3, times c, which is negative 2, all over 2 times a, which is 3. Okay, and so this is what our equation is going to look like. And so let's start simplifying this. We have this negative negative 9, which is just positive 9, plus or minus the square root of negative 9 squared is 81, minus 4 times 3, which is 12, times negative 2, which is positive 24. So we're going to get something that looks like this. And at the bottom, we have 2 times 3, which is 6. Now let's simplify what's underneath the square roots. So we have 81 plus 24. And if we do that in our calculator, we would get 81 plus 24 is equal to 105. So we're going to get x is equal to 9 plus or minus the square root of 105 all over 6. And here we could split it up into our two solutions because of that plus or minus. We're going to get x is equal to 9 plus the square root of 105 divided by 6, or 9 minus the square root of 105 divided by 6. Okay, let's find out what the square root of 105 is. So get your calculators out. And the square root of 105 is 10.25. So we're going to x is equal to 9 plus 10.25 divided by 6, or 9 minus 10.25 divided by 6. And let's just calculate what those are. So 9 minus, sorry, let's do 9 plus 10.5 first. 10.25. So 19.25 divided by 6. we're going to get x is equal to 3.21. And if we do this side here, 9 minus 10.25 divided by 6, we're going to get x is equal to negative 0.2083, or 21. We'll round it to that. So there's your x values here and here. So we can see we get some decimal values when we solve the quadratic formula. And for the sake of this class, let's keep it to round it to 2 decimal places. That way we're all on the same page when we're answering these questions, unless the actual question specifies something different. But let's just keep it to 2 decimal places for now. So let's try example 2 together here. Solve the equation 4x squared is equal to 12x minus 9. So the first thing we'll notice is that this is in standard form. So we just have to move this over to the other side to get it into standard form. So let's rewrite the equation in standard form. So 0 is equal to negative 4x squared plus 12x minus 9. And now we're in standard form. Just one thing, you can factor this one, but let's pretend you can't, and let's just practice using the quadratic formula. So what is the quadratic formula? X is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And our a and b and c values are negative 4, b is 12, and c is negative 9. So let's start plugging it in. We have x is equal to negative b, which is 12 plus or minus b squared, which is 12 squared, minus 4 times a, which is negative 4, times c, which is negative 9, all over 2a, which is 2 times negative 4. So let's start simplifying what we have here. I'll write it down here just to save some space. X is equal to negative 12 plus or minus the square root of b squared. So 12 squared is 144, minus 4 times negative 4 is positive 16, times negative 9 is actually negative 144, all over 2a, and 2 times a, that's going to be negative 8. So 2 times negative 4 is negative 8. And now this one's going to simplify nicely for us, because we have this plus or minus the square root of 144 minus 144. So everything underneath this bracket is just going to equal 0. So we're going to get x is equal to negative 12 plus or minus 0 divided by negative 8. And square root of 0 is just 0. So it's just going to be x is equal to negative 12 divided by negative 8. And this can simplify to x is equal to 1.5. So that's getting our solution using the quadratic formula here. And in this case, there's only one solution, which is 1.5, because there is no, and it's at this point we can split up into our 2 equations here for plus or minus the square root of 0, but you'll see it's just the same answer regardless. The square root of 0 is just 0, so if you had x is equal to negative 12 plus 0, or x is equal to negative 12 minus 0 all over negative 8, these are going to be the exact same thing. So negative 12 plus 0 is just negative 12 over 8, negative 8, and the same thing over here, negative 12 divided by negative 8, and so x is equal to 1.5, or x is equal to 1.5, so it's the same thing. There's only one solution to this, which is x is equal to 1.5. So here we can see how we can solve quadratic relations and solve for x-intercepts by using the quadratic formula. Okay, Let's try a word problem that we haven't seen before. We will use the quadratic formula to help us solve for the answer. A rectangular field is going to be completely enclosed by 100 meters of fencing. Create a quadratic relation that shows how the area of the field will depend on its width. Then, determine the dimensions of the field that will result in an area of 575 square meters. Round your answer to the nearest hundredth of a meter. So what do we know here? We know the perimeter is equal to 100 meters, and we know it's a rectangle in shape. And we know the perimeter of a rectangle is 2 times the length plus 2 times the width. So P is equal to 2L plus 2W. And we know P in this case is equal to 100. So 100 is equal to 2L plus 2W. Now we don't know these variables specifically, but we can solve for one in terms of the other. So let's go ahead and solve for what L is. We're going to move the 2W over to the other side, so we're going to get 100 minus 2W is equal to 2L. Now if we wanted to find 1L, we could divide both sides by 2. These two will cancel here, and this we can actually solve. This is the same thing as this. So we can just split them up, is equal to L, and we can go ahead and solve that. 100 divided by 2 is 50, and 2W divided by 2 is just W. So we know our length is equal to 50 minus W. So this is going to be equal to 50 minus W. So we know area for a rectangle is equal to length times width. In this case, we know the length is 50 minus W, so the area is going to be equal to 50 minus W times W, the width. And we can simplify this by rainbowing in the W. So we'll get A is equal to 50W minus W squared. So we just rainbow this in here and in here. So that's how we get the area in terms of width for our rectangle here, and it's a quadratic, as you can see. Then we want to determine the dimensions of the field that will result in an area of 575 meters squared. So if our area was 575, we want to figure out what our W is. And so we can turn this into a quadratic in standard form by moving this value over here, and we're going to get something that looks like this. We get 50W minus W squared minus 575. Okay, and we could rearrange this so it looks more like a quadratic. 0 is equal to negative W squared plus 50W minus 575. And now we have to solve for what W is. We can see we can't factor it, so we can use the quadratic formula to help us do it. In this case, we're solving for our W. So W is equal to negative B plus or minus the square root of B squared minus 4 times A times C all over 2A. And before we continue, let's just list out what our A, B, and C values are. So our A is equal to negative 1. Our B is equal to 50. And our C is equal to negative, let me rewrite that. B is equal to 50. And our C is equal to negative 575. Okay, so now we can start filling in our quadratic. So W is equal to negative B, which is negative 50 plus or minus the square root of B squared. So 50 squared minus 4 times a, which is negative 1, times c, which is negative 575, all over 2 times a, which is 2 times negative 1. Okay, so let's simplify what we have here. We can get just negative 50 over here, plus or minus the square root of 50 squared, which is 2500, minus 4 times a times c. So let's actually do that in our calculator right now. So we have minus 4 times a, which is negative 1, times c, which is negative 575, and we're going to get negative 2300. Okay, and this is all over 2a, which is 2 times negative 1, which is negative 2. Okay. And we can simplify what 2500 minus 2300 is, and that's just going to be 200. So our width is equal to negative 50 plus or minus the square root of 200 all over negative 2. And from this point, we can split it off into our plus and negative square roots. So let's go ahead and do that. I'll do it over here. So we're going to get w is equal to negative 50 plus the square root of 200 divided by negative 2, or negative 50 minus the square root of 200, all divided by negative 2. Okay, so we split up the plus and minus, and then we can actually solve for what the square root of 200 is. And the square root of 200 is approximately 14.14. So we're going to get w is equal to negative 50 plus 14.14 divided by 2, or negative 2. And we'll have w is equal to negative 50 minus 14.14 divided by negative 2. And we're almost done here. So we have 50, negative 50, minus, plus 14.14. Let's do that one first. So we're going to get w is equal to negative 35.86 divided by negative 2. And this one here, we're going to get negative 50 minus 14.14, which is negative 64.14 divided by negative 2. And if we do this, we're going to get both our w's, so we can just simplify this. So 35.86 divided by 2 is equal to a width of 17.93, or 64 divided by 2 is going to be a width of 32.07. So we can see that we have two different widths that satisfy our area being 575 meters squared. So we have one case where our width is equal to 17.93, and the other one where our width is equal to 32.07. Let's find the lengths for each of these widths. So we said length is equal to 50 minus w, and in this case our w is equal to 17.93. So we have length is equal to 50 minus 17.93, and if we do that, plug that into a calculator, we're going to get 32.07. Let's see if we plug in the other one here. If we have length is equal to 50 minus 32.07 here, we would get a length of 17.93. Okay, so we can see here we have two different possibilities for length and width, and we can see that they're just opposite each other. So the dimensions of the rectangle will be 32.07 by 17.93. Okay, so we can either take it as the width or the length, and we would get the same answer for an area of 575 meters squared.